This is Professor Pelton. This is part 5 of chapter 2, section 6. Not going to deal with the rational equations. So each ratio is 5 over x, 7 over 4, 9 over x. Those are all ratios. So the basic premise is you can just get rid of the ratios by doing a quick LCD trick, and it reverts back to all of the methods that we did in the past. Okay, so I'm going to see if I can get this into view with the rules for the first one at least. So if I want the lowest common denominator, I'm going to write down the word LCD. Okay. What they have in common is an x in common. And what you mean by common, doesn't have to be common between all of them, just between some of them. And what's left over is a 4. So 4x is the lowest common denominator. Okay, so I'm going to take the 5 over x plus 7 over 4 and multiply that by the lowest common denominator, which is 4x. And take the other side, the negative 9 over x, and multiply that by 4x, because what you do to one side of the equation, you do to the other. You go to the entire side of the equation, not just picking and choosing. So that's 20x over x plus 28x over 4 equals negative 36x over x. Okay, so if I simplify that, I'm going to get 20 plus 7x equals negative 36. So if I subtract 20, I'm going to get 7x equals negative 56, right? So if I go over to here, 7x equals negative 56 divided by 7, and x equals negative 8. Okay, so that's a monomial example. You could have binomials and trinomials or a mix of them. So the next question is a mix of binomials and monomials. So if I try the same trick here by using the LCD trick, this is really over 1. So LCD in common is nothing in common. What's left over is a 1, an x, and an x plus 5. Okay, because they have nothing in common essentially. So one of them is a constant, a 1, one's a monomial, an x, and one's a binomial, an x minus 5. Really, binomial is x minus 5. Okay. So 1 minus 8 over x minus 5, and we'll multiply that by the LCD, which is x minus 5 on this side. I don't know why that came out like that. That's kind of weird. Okay, and over here on the right-hand side, we have 3 over x times the x minus 5. Okay, because what you do one side of the equation, do the other. All right, so this is 1x, x minus 5, minus 8x, x minus 5, over x minus 5, equals 3x, x minus 5 over x, right? Because essentially we're distributing this into there and this into there, correct? So if we simplify, we get 1x squared minus 5x, right? This cancels, even be minus 8x equals 3 times x minus 5, right? Because the x's cancel there. So this is clearly a factoring problem because we have x squared and x, so it's going to be a factoring problem. So 1x squared minus 13x equals 3x minus 15. So if I minus the 3 and add the 15, I get 1x squared. Let's see, if I minus, we go minus 16x, right? And if I add 15, it's plus 15, correct? Okay, let's see how my spacing is here, 15. Looks like I'm good, so I'm going to do 1 times 15 is 15, right? So 1 times 15, oh, what is going on? Try this again, 1 times 15, or double negative, right? And 3 times 5, 3 times 5, double negative. I think that's it, because 2 doesn't go in, 4 doesn't go in. And I want negative 16, so this is my correct factors to be able to do this. So if I factor this out, it's 1x equals 0 divided by 1. The correct factors were negative 1 and negative 15. So I have x minus 1 is equal to 0, and x minus 15 is equal to 0. So x is equal to 1, and x is equal to 15. What you have to check is make sure that it doesn't fail any of these denominators, because if it fails any of those denominators, because you can't divide by 0, wouldn't be an answer, so we're good here. So in fact, both of these are in fact solutions. Okay, so the first problem was monomials. This was a monomial and a binomial. So the third example has constant and binomial, and it has some factoring that we have to do. Because if we rewrite this problem, what we really have is 7 over x minus 1 minus 5 over 1 equals 6 over x minus 1 x plus 1, right? Because what you have to remember is this term right here is actually x squared plus 0x minus 1. So plus 1 and minus 1 will give me the 0x. Okay, so my lowest common denominator, what they have in common is an x minus 1. That's what they have in common. What's left over is an x plus 1 and a 1. Oh, the x plus 1 kind of went sideways on me. Let's fix that. Okay, because again, common only has to be common between some of them, right? And what's left over is whatever wasn't in common, essentially. Okay, so I'm going to rewrite the problem now. Leave myself plenty of room here. So 7 over x minus 1 minus 5 parentheses equals 6 over x minus 1 x plus 1. Okay, multiply this side by x minus 1 x plus 1, which is the LCD. Multiply this side by x minus 1 x plus 1, which is the LCD. Okay, I'm leaving the 1 off because we really don't need the 1 on the LCD. So we have 7 times x minus 1 x plus 1 over x minus 1. Fix that parenthesis there. Minus 5 times x minus 1 x plus 1 equals 6x minus 1 x plus 1 over x minus 1. Come on, it died on me. X, there we go, x minus 1 x plus 1. Okay, so the x minus 1's cancel, leave me with 7x plus 1 in the first term, minus 5 times x squared minus 1, if I distribute all that, right, equals 6. So I have 7x plus 7 equals, minus, I'm sorry, minus. That's incorrect. Minus 5x squared plus 5 equals 6. Okay, let's just pause and take a breath here, make sure I didn't mess up any. I think I'm good. So I need to get, since I see an x and an x squared, this is a factoring problem. I'm going to move everything to the right-hand side so I get a positive. So 0 equals 5x squared, right? So I'm going to move the minus 5x to the side because I want a positive leading term. Then I'll have a minus 7x and I move that. So 7 plus 5 is 12. If I minus that from 6, I get minus 6, right? Okay, so now I can factor this, correct? Yes. So 0 equals 5x, 5x, all over 5, okay? And 5 times negative 6 is negative 30, right, which is 1 times 30, 1 times 30, 2 times 15, 2 times 15, 3 times 10, 3 times 10, 4 doesn't go in, 5 goes in, right? 5 times 6, 5 times 6. So one of these has to be the right one. So we're trying to get negative 7. So that's going to be the right one there. Positive 3 minus 10. That'll give us negative 7. Okay, so if I break that down, I get 0 equals 5x plus 3 times 5. I take a 5 out, I'm left with 1x minus 2. So the 5's will cancel at that point, right? So I think we're good there. So 5x plus 3 is 0 and x minus 2 is 0. So x is 2 and 5x is negative 3, or x is negative 3/5. We have to go back to the original and make sure none of those fail. So if I plug that into the original denominators, neither one of those is going to give me 0, so I think we're fine because we can't divide by 0. So these both are good answers. Okay. All right. So I gave you a mixed bag of the different categories of rational functions. What I want you to do now is pause the video, try the student problems on the next page. Okay, page 19. So again, this is all monomials in this case, so we want the lowest common denominator, and what they have in common is an x. They have a common x, and what's left over is a 5. Okay, because common is not necessarily between all of them, it could be between some of them. So 15 over x plus 4 over 5. I'm going to do parentheses and times it by the lowest common denominator, or lowest common multiple if you just want to call it that, equals 7 over x times the 5x there. Okay, so on the left-hand side, I get 75x over x plus 20x over 5 equals 35x over x. Okay, so we have 75 plus 4x equals 35 when I simplify. So there's only one x here, so we can do isolation method. So if I subtract 75, right, I'm going to get 4x equals negative 40. If I divide by 4, leave myself room here. I did. I get x is equal to negative 10. Does that fit in there? Yeah, because if I plug in negative 10, that's not 0 on the bottom, so that'll work. Okay, so that's a monomial example. Okay, so next one is a mixed bag of binomial and monomial. Come on. Okay. So, lowest common denominator. What they have in common is a 2 and an x. They have a 2 in common and an x in common. What's left over is an x plus 1. Okay, so some monomials and a binomial there. All right, it's going to rewrite it 3 over x plus 1 minus 5 over 2x and 3 over 2x. So 2x times x plus 1. 2x, x plus 1. So I distribute now, right? Because this has got to go to here and here, and this one has to go into here, right? Okay, that's 6x, x plus 1 over x plus 1 minus 10x, x plus 1 over 2x equals 6x, x plus 1 over 2x. Okay, I think that's right. So that's going to leave me, that's the first one, right? Oh, I forgot the x right here. So that's a square. I felt like something was wrong. Yeah, because I rewrote the problem incorrectly. All right, so 6x squared. So those cancel. I get 6x squared. This makes more sense now. Okay. And then that's going to cancel, giving me minus 5 and x plus 1. Because the x's cancel and 10 divided by 2 is 5. Equals, that's going to leave me with a 3 and an x plus 1. Okay. I'm liking this now. All right, so what I get is 6x squared minus 5x minus 5 equals 3x plus 3. So that's clearly a factoring problem since I have x's and x squareds, which is what my original hypothesis was. So 6x squared, so minus 3, I get minus 8x. If I minus 3, I get minus 8. Okay, I like it. All right, so I could factor out a common term. I'm not going to do that though. We'll just go over here and break this down. So 6x equals 0, and then divide by 6, right? So 6 times negative 8 is negative 48, right? So you need a factor tree for negative 48. So that's what, 1 times 48, right? Or 2 times 24. And 3 goes into what, 16 times, right? 4 and 12 times. And we can keep going, but we don't need to, because we need a negative 8. So clearly it's this one here, which is positive 4 minus 12, right? That gives me my negative 8 in the middle, right? And the 6 times negative 8 is the negative 48. Okay, so if I rewrite this on the right-hand side, 6 and 4 have a common factor of 2. So that's going to leave me with 3x plus 2. All right, and 6 and 12 a common factor of 6. So that's 1x, what does it be, minus 2? So that'll cancel the 6, which is what we want, right? So I think this is looking good so far. Yep, so 2 does not equal 0, that's obvious, right? 3x plus 2 is equal to 0. X minus 2 is equal to 0. So x is equal to 2. 3x is equal to negative 2, or x is equal to negative 2/3. All right, so we double check. Are any of those going to give us 0 denominators? No. A 0 would and a negative 1 would, but neither of those is an answer. So those are in fact our 2 answers. Okay, all right, let's try the last one. So the last one, I'm going to do a little bit of factoring first. So if I rewrite the problem here, I get 4x plus 1 over x plus 1 binomial equals 12 over x plus 1, x minus 1 plus 3 over 1. So the lowest common denominator, what they have in common is an x plus 1. What's left over is an x minus 1. Whoops, that didn't work. It like jumped on me. X minus 1, there it goes, and a 1, right? That's left over, and that's what's in common. Okay, so let's rewrite the problem again. I'm going to write the LCD first, so I space this out very well. X plus 1, x minus 1 times the left, which is 4x plus 1 over x plus 1, right? X, come on, x plus 1 equals, right, the right side, 12 over x plus 1, x minus 1. Oh, we're so close to done, the pen's dying. All right, times x plus 1, x minus 1. Okay, so on the left-hand side, we get x plus 1, x minus 1, 4x plus 1 over x plus 1. Oh, we forgot the plus 3. Crap. Plus 3, x plus 1, x minus 1. There we go. All right, so equals 12 x plus 1, x minus 1 over x plus 1, x minus 1 plus 3, x plus 1, x minus 1. Okay, so over here the x plus 1's cancel. I'm left with x minus 1 and then 4x plus 1. Over here I just left with a 12 because all of those cancel, and then plus 3 times x squared minus 1, which is what happens when you distribute those back to the original, right? So if I distribute these over here, I'm going to get 4x squared plus 1x minus 4x minus 1. I like that. And over here, I'm going to get a 12 plus 3x squared minus 3. So I have an x and an x squared. So that means this is going to be a factoring problem. I'll move everything to the left so I get a 1x squared, right? So if I minus 3, I get 1x squared. And I have negative 3 on the left. Then I have a negative 1, and I have a 9 on the other side. So if I subtract 9 from negative 1, I get negative 10. Okay? So all I have to do at this point is factor, which I'm going to factor over here, right? Because I ran out of room. And spaces very well, so it's 1x over 1, and I'm going to get 1 times negative 10 is negative 10, right? Which is 1 times 10, or 2 times 5, and one of them has to be negative, right? So I'm trying to get a negative 3, so that's clearly the 1 right there, right? So x plus 2 is 0, x minus 5 is 0. So x is negative 2, x is 5. I checked the original problem. Neither one of those will give me a 0 denominator because you can't divide by 0. So those are both valid answers. Okay, that's the end of this part.